The number I is what we know as the imaginary unit. What we know about I is when it's squared, it is equal to -1. And anytime something is squared, it's equal to, let's say, 100. If you square root both sides, you know what it is by itself. It's just going to equal the square root of 100. So let's do that right here. Let's square root both sides. And now we see that I alone is equal to the principal square root of -1. And we also know that I squared is equal to -1. So these are the two things that we know so far. Let me clear up some space. Alright, so we know I alone is equal to the principal square root of -1. And we know I squared is equal to -1. Now let's see what would I to the power of 3 equal. Alright, I to the power of 3 is simply I squared times, times I, right? And we know I squared is -1, so we can simplify this as -1 times I, and that's just going to give you -I. So we know the I to the power of 3, I cubed, is -I. Now let's move on to I to the power of 4. Now this is simply, this is simply I to the power of 2 times I to the power of 2. And we know I to the power of 2 is -1, so we can simplify this as -1 times -1. That's going to give you 1. So we know I to the power of 4 is simply 1. Alright. Some things you already know because of the exponent law is anything to the power of 1 is itself, and anything to the power of 0 is 1. Example is if you have 100 and it's to the power of 1, anytime something is to the power of 2, 3, that is how many times you're multiplying it by itself. So example 2 to the power of 2 is 2 times 2. You're multiplying it. There's 2 2's. Literally, there's 2 2's. So anytime it's just to the power of 1, it's just itself. So we know this applies to I. So we know from this, we know that I to the power of 1 is itself, and I to the power of 0 is 1. Alright, so this is how much we can know, right? I stopped at 4, and I went from 0, 1, 2, 3, all the way to 4, and we have I by itself. Now let's say, okay, we went through 1 to 4, 0 to 4. Say if you wanted to find I to the power of 8. Now what would you do now? You see, you might get a little confused here, but I stopped because there's a pattern. We started off by I by itself. I by itself is, that's a little too small. I by itself is the principal square root of -1, and then I squared is -1, and then I cubed is -I, and then I to the power of 4 is 1. This is the first, second, third, and fourth. Alright, let me switch the color. Alright, so now that you see I to the power of 8, you're going to see, okay, let's see what number this falls under. So we go through 1, 2, 3, 4, and now we start over because it's a pattern. 5, 6, 7, 8. Oh, it stopped at 4. I to the power of 4 is equal to 1. So that means I to the power of 8 is equal to 1. So anything that would be divisible by 4, say you have I to the power of 16. You see, we go over this. We'll move a little forward. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It falls under 4 again. So I to the power of 16 is still 1. So this is basically the pattern that you see. From 0 to 4, you have the principal square root of -1, and then you go to -1, and then you go to -I, and then you go to 1. So this is the first, second, third, and fourth. Alright, that's some background information about the imaginary unit, which is I, and what it is alone. We know that it is the principal square root of -1. I squared is equal to -1, and we found out by simple exponent laws and properties, we found out these other squares of I.